Bismillahirrahmanirrahim. Assalamualaikum and good days to everyone here. This project is about investigating the impact of marker and markerless of augmented reality AR apps in enhancing learning for welding process in UIT MPP. Our paper ID is number 47. My name is Rohidatun Elias Wahab as presenter for this project. Industry requirement change every year as the global competition drive continuous technological advancement. For the emerging technologies are very challenging the way we work, play and live. For the industry 5.0 is actually refers to how the intelligent robots and machines collaborate with the human by also aiming to be resilient and sustainable. Industry 5.0 is strive to reintegrate human and environmental and also for the societal factors into the equation. Industry needs to transform into dependable resource of prosperity to ensure that production adheres to the environmental regulation and also prioritize for the welfare of industry workers. Welding is commonly used for especially joining metal parts between part A and part B. Even though in some industry, especially for the automotive part, welding is done by robotics or automated machine, but most of the welding process need to be done by physical labor. That means performed by human. Thus, for the development of new welders is very important to enable for the business and field of the vocational education and industrial sector. Moreover, for the future technology, it's expected that training would be effective, especially for the welding process. Why augmented reality applicable to give an industry for better consideration how it enabled to be core competencies that reside in multiple across all industry. AR offer with useful interactive tool, especially for reducing the cognitive load by creating a connection between the physical task and supporting the documentation. It will display the information without interfering with user ability. The AR applications are highly valuable, especially in the manufacturing industry. Moreover, the implementation of AR apps will enhance the working experience as well as delivery information to the new user, especially for the learning and training in education, medical sector, sales, marketing, sport and entertainment, design and modeling and so on. For the research methodology, this study was chosen the shielded metal arc welding process (SMAW) as the virtual scenario for the learning and experience welding using an AR apps. This study aims to design and develop an augmented reality AR apps as learning tool for the welding process. Then, to investigate the impact of marker and markerless of an AR apps in enhancing learning for the welding process, especially for the UIT MPP. This study began with the finalized act focusing on the information regarding training tools, safety equipment and procedure, especially for the SMAW process. The model of the relevant SMAW training tools were designed using SolidWorks software. Then the 3D CAD file needs to be saved in STL format before importing into the Blender software. After creating the animated scenes, visual effect and so on, it then put the 3D file into FBX file to be imported into Unity software. Okay, this is the flow diagram of AR architecture. After completing design the 3D model in the SolidWorks and Blender, next Unity software was used for the development of an AR apps. For creating the different visual scenes, especially for the fundamental in the smart process that required programming using C+ language. Next, for the development of main menu was created in this canvas. While for the QR code was created using QR code generator website. The use of QR code is crucial for the functionality of the AR itself. It works as an identifier, which is visual image will appear when scanning the QR code using mobile devices camera. Next, boot and run all scenes from the Unity file into APK file to ensuring the integrating with mobile Android. For the experimental work, a total 20 student diploma in mechanical engineering, especially from Part 3 from UIT MPP, were involved in this evaluation process. There were two groups assigned for the experimental work, which is AR marker group compared to the AR markerless group. Okay, there are different between marker and markerless. In discussion, the average age of total of 20 participants are 19 years old. They are come from Part 3 student diploma mechanical engineering. They were divided into group balance, 10 participants in AR marker group while another 10 participants in AR markerless group. Data shown that 80% of the participants from the AR marker have an experience in welding, while only 60% of the participants experience for the AR markerless group. Okay, then 90% of AR marker group have more experience with augmented reality compared only 80% from the AR markerless group. Graph 1 shows the task completion time TCT recorded for each task to be complete by each participant. Participants will repeat the same task for 5 times. In overall, both types of AR are constantly decreasing for the time taken to complete each task. However, AR marker groups have higher, bigger decreasing time in order to complete the task that result in a lower TCT compared to the AR markerless group. Therefore, this finding shows that the more repetition or rehearsal given, it will result in more efficiency, efficient, and may increase the feasibility of implementation of this AR technology, especially for the educational and also for the industrial training purpose. While for the graph number 2 shows the result for the average task completion time taken for both groups. It clearly shown that AR marker has better result, which is less compared to the AR markerless. It shown that AR marker groups reveal improvement in overall TCT compared to the AR marker groups. This finding also fits similar with the previous study done by 2017, which is they found out that AR marker tend to have higher accuracy and more stable compared to the AR markerless. Graph number 3 shown that the average score for the learning curve was decreased as the number of repetition participants take increased as they gain experience and knowledge. Even though AR marker group is showing decrease much better compared to AR markerless for the every trial, it also shown that learning curve in this context also was influenced by the quality of both AR apps, which is to in order to complete each task. Besides, participants for both type of AR apps also able to answer the technical test question most correctly and got average score of 90%. Hence, this finding proved that both AR apps bring positive impact, especially for the participant. That means it shown that AR training apps manage to deliver information clearly, especially for the new user. Next, graph number 5 shown the result for the user experience questionnaire UEQ. In overall, AR marker group score slightly higher compared to the AR markerless group, especially for every section such as for the efficiency, dependability, and stimulations. This result is might due to the AR marker provide more visible and clear simulation, which is increase their understanding very well. Throughout this research, the results shown that both AR apps were effectively as desired in order to expose user, especially for the fundamental of new procedure with added of simple animation for better understanding. Therefore, new user may experience at early exposure for new procedure by implementing these AR apps. Conclusion: the objective of this study was successfully achieved for the design, develop, and evaluate for the AR apps for the learning and training in welding process. This finding show that AR apps effectively as a desired to expose new user, especially for the fundamental of new procedure, especially for the small process with the aid of simple animation. Besides, these AR apps might be used in future education and also for the learning and training in industrial sector, especially to be implemented with these current technologies. If you have any inquiry or would like to discuss about this research, you may contact or email me as a corresponding author. Thank you.